All right, so here we go with 4.5. So 4.5, it's all about solving rational equations. So we want to figure out what x is in here, okay? And we're going to use that same technique that we used in 4.4, where in order to solve for these x's, we need to clear out the fraction, okay? So that means, again, we got to find that LCD. So we've been working on LCDs. This is the third section. So I'm going to write down my denominators, x, 3x, and 5. And then the LCD is going to be made up of all three of those. Remember, as we said, and I told you that technique, go ahead and write down the first denominator, okay? And we work it out from there. So my first denominator is x. And does x cover 3x? Well, the x covers the x part, but it doesn't cover the 3. So we'll modify. We'll put a 3 in front. Okay, so 3x definitely covers 3x, and 3x definitely covers x. But does 3x cover the 5? No. So I need a number that is made up of both 3 and 5, and that number will be 15. So 15x is the LCD that covers all three of those. So we're going to play Oprah, and everyone's going to get multiplied by a 15x. So you get a 15x, and you get a 15x, and you get a 15x. Everyone gets a 15x. Okay? And remember, the object, the idea behind here is we are clearing the fraction. So what's going to happen between these two? The denominator goes away, and it also cancels out that x. So what we have left is 15 times 1, and that's 15. Plus, so what's going to happen between these two? Well, this x and that x are going to cancel, and the 15 and the 3, there'll be some reducing from there. The 3 goes away, and then the 15 becomes a 5. So what's 5 times 2? 10. Okay? Equals, and then what's going to happen between these two? Well, this 5 is going to cancel out because, again, we're clearing the fraction, and that's going to reduce some of the 15, and the 15 is going to become a 3. So we have 1 times 3x, which is 3x. Now this is really easy to deal with. Okay, we can definitely solve this. So let's go ahead and just solve the rest of the equation. We're going to put like terms together. So 15 and 10 give me, put 15 again, 25, equal to 3x. So then all we got to do now, divide by 3, divide by 3. X is equal to 25 over 3. Now, the one thing that you have to be careful of in this is that in the end, you have to check your answers because it is possible that this answer is a lie. You've got to check them. And by checking them, I erased all the little marks I put over the denominators because what you're really checking is we want to know if I plug in this 25 over 3 in for x here and x right there, does that create 0? Because we cannot have 0 in the denominator. If it does create 0, then we have to throw this out. If it doesn't create 0, then this answer is good to go. So if I put 25 over 3 in for x right here, is that 0? No, that's 25 over 3. That's certainly not 0. If I take 3 times 25 over 3, does that give me 0? No, it actually just gives me the number 25. So does plugging in 25 over 3 give me zeros up here in my denominators? Nope. So this answer is A-OK. So I got 3 more here. Let's go ahead and do another one together. And then I'm going to show you the last 2, and you'll pause the video and go at them. So on this guy, what are my denominators? X and x squared. So we need to find the LCD. Again, what's the LCD going to be for this? Again, it's got to be made up of both of these. Hopefully you're getting better and better at the LCD by now. You've had lots of practice. So the LCD is x squared. So everyone's going to get multiplied by x squared. So the 1 gets multiplied by x squared, even though it doesn't have a denominator. Or, well, it really does. It's all over 1, but we don't worry about that. The 1 over x gets an x squared, and you get an x squared. Okay? So again, now we just start seeing what we have left after we clear these fractions. So there's no fraction to clear here. So what's x squared times 1? X squared. Okay? Well, here, we're just going to, this x is going to go away. And this was a battle. This guy won, leaving you with only 1x left, because this x took out one of those two x's up above. So we've got minus, what's 1 times x? X. Equal to, well, these two are just going to take each other out. Okay? And all we have left there is 30. Now, hopefully, when you look at this, because this is all we have to solve, your gut is telling you, man, this looks like factoring, because I have an x squared and things like that. And you're absolutely right. Factoring is what we want to do to solve this. Okay? But in order to solve by factoring, you're going to find out that we have to be set equal to 0. So this equal to 30 part is messing us up. So we need to fix that. Because again, in order to solve using factoring, you have to be equal to 0. So we're going to subtract 30, and that's going to give us x squared minus x minus 30 equal to 0. And now that we have this set equal to 0, we can solve. And again, using your factoring skills that I told you that you need to be able to do, you're going to end up with x minus 6, x plus 5 equal to 0. And as we did all the way back in 4.1, when your denominator was set equal to 0 and we factored it, what do we do with these two parentheses to solve for x? You set them equal to 0. Because we're using that 0 product rule. So, what does x equal when x minus 6 equals 0? X is equal to 6. Over here, when x plus 5 equals 0, what does x equal? Negative 5. Okay? So, again, we have to check these. So, again, all we're looking for is, does that create 0 in the denominator? So if I take 6 and plug it into these two denominators, does that create 0? No. This denominator right here is 6. This denominator over here is 36. So this is a valid answer. Does plugging negative 5 in create 0? No. This is a negative 5. This becomes a positive 25. So this is a valid answer as well. All right, so I got 2 more. And then you have the other 3 videos to watch. Or actually, sorry, the other 2 videos to watch. So, dual page this. There are the 2 problems. Go ahead, pause the video, give them a shot. Okay, so let's do these. Going back to this guy. So dealing with your LCD, you got the 4. That's a horrible 4. We've got 4, 7, and x. The LCD for this guy, well, it's going to be, I believe that's 28. No. Maybe. Yeah, 28. 28x. So everyone's going to get multiplied by 28x. you get a 28x, and you get a 28x, and you get a 28x. Okay? So let's see what happens. So this 4 cancels out with some of that 28, leaving you with a 7. So 7x times 1 is 7x. This 7 cancels out with that 28, leaving you with 4. 1 times 4x is 4x. Equal to, these x's are just going to cancel each other out, and 1 times 28 is 28. So we're going to take the 7x and the 4x and put those together because they're like terms, which will give you 11x equal to 28. Divide by 11, divide by 11, x is equal to 28 over 11, and that does not reduce. So again, we come up here. If I take 28 over 11 and plug it in for x, does that give me 0? No, it does not. It gives you 28 over 11, so this answer is good to go. All right, last problem. Hopefully you see that everyone needs to be multiplied by an x minus 1 because that's the only denominator. So you get an x minus 1, you get an x minus 1, you get an x minus 1, and you get an x minus 1. So seeing what we have left, these x minus 1s cancel. That gives us 13. Plus, these x minus 1s cancel. That gives you 7. Well, the 5's got to get multiplied through the x minus 1. So that will give you 5x minus 5. Okay? And then these x minus 1s cancel, which will give us plus 20. Okay? So now we need to combine some like terms. The 13 and the 7 will get together over here, giving you 20. Equal to, over here, this negative 5 and this 20 will get together. So that will give us 5x plus 15. And continue to solve, so we will subtract 15, and that gives us 5 equal to 5x. Divide by 5, divide by 5, x is equal to 1. So we come up here. If I take 1 and plug it into my denominators, does that create 0? And it does, because 1 minus 1 is equal to 0. So what does that mean about this answer? It's poo-poo. So we throw it out. So now we have no more answers left. Hopefully you realize that since we had no answers left, the answer to this problem is that it's a no solution. Or it's a DNE according to IMathAS. Okay? Yeah, if you throw all your solutions out, it's a no solution. Okay? And there it is. That's how we solve rational equations.
Okay, guys, here is the rest of 4.5. So, when we're dealing with rational word problems, basically what you're going to be doing is you're setting up 3 fractions. And how these problems will be laid out, it's going to talk about like 2 items, or in the case of this one, it's going to talk about 2 people, one being Alan and one being Frank. So let me read this problem real quick. It says, it takes Alan 3 hours to wax the floor of to wax the floor of building 1. It takes Frank 6 hours to wax the same floor. How long will it take if Alan and Frank work together? So you're setting up 2 fractions, and your fractions are basically 1 over the number for that person or for that item, because it takes Alan 3 hours. But if you thought about it as a fraction over each hour, Alan is really doing only a third of the work every hour. So that's why we get that fraction, because it's 1/3 for every hour. Okay? And then you get the same kind of fraction for Frank. It takes Frank 6 hours to do that same floor, but since we're going to worry about what happens every hour, Frank is only doing a sixth of that floor every hour. In the end, we want to know, well, what happens when they work together? And of course, if you work together, things should go by faster. So we want to know what's going to happen when they work together, which will look like 1 over x. So we want to know how much do they get done working together for every hour, which it will be the 1 over the x. So all we got to do is solve this, just like how we solved all the other rational equations that we've been dealing with. We got to get that LCD, and the LCD for this is 6x. So everybody's going to get multiplied by 6x. You get a 6x, and you get a 6x, and you get a 6x. And remember that we're multiplying by this LCD because we are clearing the fractions. Clearing the fractions. So the 3 goes away. The 6 divided by 3 gives you 2 because part of that 6 is still there. It didn't cancel it all the way out. So what do we have left here? 2x. Because you got the 2 and the x, and we're multiplying the 1. So over here, when we move to the next guy, the 6 and the 6 cancel out all the way. What do we have left up on top? Plus 1x. And then when we roll over to the other side, we have the x and the x going away, which leaves you with 6. So once we clear that fraction out, you can see a nice, simple, easy equation to solve. Nothing like what we had the other day, so don't freak out. These will be nice and short. So all you got to do is combine like terms. So what is 2x and 1x? That gives us 3x equal to 6. So do a quick division, and you find out that it will take them, if they work together, 2 hours. 2 hours to complete it. Or in other words, when you think about it, every hour they get half of the job done. So 2 hours. All right, so let's take a look at another problem, and let's get used to this. Again, remember, it's all about writing those fractions. Each person or item they talk about is a fraction. Okay? So in this case, we're going to be talking about Lisa, and we're also going to be talking about Megan. So let's talk about these two real quick. So it says Lisa estimates that it may take her 12 months to work on an algebra book. Megan estimates that it will take her 18 months to work on a similar algebra book. They realize that it may take them fewer months if they work together. Were they right? Well, of course they're going to be right. When you and a friend team up, things will get done faster than if you were doing them by yourself. I guarantee it. Okay? So we really want to check how long will it take if they actually work together. So Lisa, we know that it takes her 12 months. So as a fraction, that means Lisa is 1 out of 12. So that means it takes, every month, she's doing 1/12 of the book. Okay? If we talk about Megan, she says it takes her 18 months to work on a similar book. So if we talk about Megan, every month she's doing 1/18 of a book. So, of course, they're going to be working together. So we get the 1 over the x, because that's what we want to figure out. So, again, clear those fractions out. Find that LCD. And the LCD for this is 36x, because that's what's going to encompass the 12, the 18, and the x. So everybody gets multiplied by a 36x, a 36x, and a 36x. So let's find out what we have left. Well, we know the 12 and the 36 cancel out with each other, but the 36 doesn't go fully away. It actually leaves you with 3. So what do we have left up here? 3x times 1, which is 3x. We know the 18 and the 36 will cancel, but of course the 36 becomes the number 2. So what do we have left up here? 2x times 1, which is 2x. And then over here, because my board is acting up real quick, we'll fix this. Whee! There it goes. And the x's will cancel out, leaving you with 36. So now we have a nice simple equation that we can solve really quick. All we have to do, put those like terms together. 3x, 2x, give us 5x equal to 36. And then when you do your quick division of 5, you find out that x is equal to 36 over 5. But since this is a word problem, that is a weird answer. It takes them 36 over 5 months. Weird. Okay, so since this is a word problem, I will allow you to do the division and figure out what the actual number is. So if you actually take 36 divided by 5, you get 7.2 months. So if they work together, they get it done in 7.2 months. Okay? So now it's your turn. I've got two problems, just like what we kind of talked about here. I'm going to show you the first problem, read it to you. Then I want you to pause the video, give it a shot, and then watch the rest of the video to see how well you did. And then I'll show you the second problem. I'll read it to you. You'll pause the video, give it a shot, and then watch the rest of the video, and that'll be it for the word problems in 4.5. So let's get started. So it says that it takes Hamid 2 hours to wax the floor of building 1. It takes Juan 3 hours to wax the same floor. How long will it take if Hamid and Juan work together? Try it. So the Hamid fraction looks like 1 over 2. The Juan fraction looks like 1 over 3. And this is all equal to 1 over x. Your common denominator for all this, that LCD is 6x. So everyone gets multiplied by 6x. You got some canceling. The 2 goes away, which reduces the 6 to a 3. So that leaves you with 3x. The 3 goes away, which reduces the 6 to a 2. So that leaves you with 2x. The x's go away, which leave you with 6. All you got to do now, just like before, combine those like terms. 5x equals 6. Do your quick division of 5, because you want x by itself, and you get 6 over 5. But again, that's weird. Okay? So go ahead and do the actual division, and you find out that it takes them 1.2 hours if they work together. And there you go. Here's the next problem. Zwadi estimates that it takes her 3 months to review an algebra book. Martha estimates that it will take her 5 months to review a similar algebra book. They realize that it may take them fewer months if they work together. How long will it take if they work together? Try it. All right, so again, we got Zawadi, who is taking her time with 3 months. And then we have Martha, who takes her time with 5 months. So those two fractions, one looks like 1/3. The other one looks like plus 1/5. And in the end, they're working together. So that LCD, the common denominator you want, is 15x. So we're going to multiply everybody by 15x. 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 So again, when we multiply by this, there's some reducing. The 3 reduces some of the 5. And then my little line just bounced around on me. We'll put that right back where it goes. So the 3 reduces some of the 15, which gives you 5 here. So that leaves us with 5x. The 5 reduces some of the 15, which leaves you with 3. So there's a plus. Doing some weird things here. Sorry, guys. Close all tabs. Go away. So that again, back to what we had. We had the 3x and the 1, which gives us 3x equal to the x and this x cancel, leaving you with 15. So again, you're at that very end piece. You got this small little fraction that you got, or not fraction, equation that you got to deal with. Put those like terms together. It gives you 8x equal to 15. Do your quick division. X is equal to 15 over 8. But again, we'll want to figure that out because 15 over 8 is just a weird answer. So in the end, if Zwadi and Martha work together, it will take them 1.875 months. So that ends the word problems. Go ahead and bring up the next video, which is over literal equations. So here's the rest of 4.5. The end part is all about literal equations. And you've actually been dealing with literal equations for quite some time. Remember when we were back in, I believe it was in Module 1 when we were talking linear equations. And I said, hey, can you take this standard form and turn it into slope-intercept form? In other words, can you get y by itself? That was a form of literal equations, linear style. Okay? And then we also did the same thing when we were in Module 2, when we did systems of equations. When you guys were doing the substitution method, you were actually doing literal equations when you had to meet the goal of substitution by getting a variable by itself that had the number 1 in front of it. So this time we're going to look at literal equations again, but this time it's going to be geared more towards rational rational equations. So I've kind of written up some steps here for you to follow. So some steps to solving literal equations. So the first thing is, like what we've been doing in 4.4, you want to clear those fractions. Okay? And once you clear those fractions by multiplying by the LCD, there is a chosen variable that they told you that they want you to look for, that they want you to get by itself. So step 2 says collect all chosen variables on one side of the equal sign. Now if you don't understand what this means, you will here in a couple minutes. But basically whatever our chosen variable is, we want to get everybody on one side with that variable and everybody else that does not contain that variable away from it. And once you do that, you'll actually see that sometimes you'll have your chosen variable appearing twice. And if that chosen variable appears twice, you're going to pull out a GCF, which that GCF will actually be that chosen variable. And again, if you don't understand that, you're going to see that here in a second when I walk through some problems with you, and you'll understand exactly what I meant by that. And then the last thing you're going to do is you're going to divide all those extra variables away that are next to the chosen variable. You're going to divide by all those variables, and you're going to get them out of there, and you're going to get that variable that you want by itself, because that's always the goal of literal equations, is to get that variable that you want, the chosen one, by itself. So let's start walking through this. Feel free to make sure that you pause this, write this down, and you're going to hear me talk about each one of these steps as we go through these next 3 problems together. And then again, I'll shift it over to you, and you'll get your shot at doing another set of 3 problems. Okay? So here we go. So the first little equation, A equals B divided by C plus 1, and they want you to solve for C. So this is the chosen variable. We want to get it by itself. Now remember what we just talked about a moment ago. Step 1 is to multiply, or to clear all fractions. So that means we need to multiply everybody by the LCD. Well, the LCD that you have, there's only one up here. There's only one denominator, and that's C. So everybody gets multiplied by C, because that's the only denominator, and we want to clear those denominators out. So obviously those guys cancel, but let's write down what's left. So over here on the left side, you have C times A, or A times C, however you want to write it. Here, because those C's canceled, you have B left, and then over here you have C times 1, which is 1C, or C if you really wanted to. You don't have to have the 1 there. Now, Again, this is what I was talking about in that step 2. Do you see how I have two sides with my chosen variable? I have it twice there. I need to get that chosen variable all onto one side. And in fact, I want to pick this guy up and move it over here. Okay? You need to get your chosen variable all on one side. That's what step 2 is all about. Get that chosen variable so it's all isolated on one side. So how do I move a plus 1c? Well, you just got to subtract it. So, sorry, I wrote a plus. We're subtracting. Silly me. Minus 1c. Now, since I subtracted, if you look at these two guys that are over here, the CA and the minus 1C, you can't put those together. Because again, remember the basic rule of combining like terms. They have to be the same. And CA has two variables, where C only has the one. So what we have over here is CA minus 1C. Over on the other side, we just have the B left. So do you see how we have now gotten the variable that we wanted all by itself on one side? Now for step 3. Remember in step 3 I said that you'll be doing this if you notice that your chosen variable repeats. See how we have two C's up here? It's repeating. So that's a hint and a half for you that you need to pull out a GCF. And again, I already told you what that GCF was going to be on the previous slide. If you look right here, I said your GCF was going to be that chosen variable. So back at this problem, what is the GCF I need to pull out? I need to pull out C. What does that leave me with? A minus 1 equal to B. And then now we're ready for that final step, step 4. So step 4 is we're going to divide all those extra variables away from C, because that was my chosen variable. Everything was always about getting this guy by itself. So who are all my extra variables? That's the A minus 1. I'm going to divide those away. And the reason why I'm dividing, because between the C and the A, woo, that guy is moving around. Between the C and the A, that's multiplication going on. That's why we have to do division. So in the end now, we know what C equals. C equals B over A minus 1. That's what they're looking for. When you guys are doing these literal equations, you're not going to come out with a single number answer. It's impossible. Especially in this case, we have 3 unknowns. Our 3 unknowns were C, A, and B. There's no way that you can come out with a one number answer that says C is 5. It's not going to happen, guys. You're going to have an answer with all those variables in it. So again, kind of to run down all those steps we just kind of talked about. So here is step 1, where we cleared the fraction. We multiplied everybody by the LCD, which was C. Right below that, this all from here to here was step 2, where you got the C all on one side. You got your chosen variable all on one side of the equal sign. This guy right here, this was step 3, where you pulled out that GCF of C because you had 2 C's that repeated. So that's a GCF. And then you saw step 4 right here at the bottom, where you had to divide by all those extra variables that were by your chosen variable, in our case, C. Again, it's a lot of abstract things going on here. It takes a little bit to get used to. This is just one problem. Try some more. So let's move to the next guy so we can get another example of this. So here, guys, I'm going to tell you real quick. I'm putting stars up here around this guy because this is super important for us. This problem right here, I promise you, you will see on your homework, you will see in your assignment, well, homework, assignment, sorry, both the same thing. You will see on your quiz, and wink, wink, nudge, nudge. You might even see this on the test. So make sure you pay close attention to this, because probably what I'm going to do is I'm just going to take the M, N, and P and change it for X, Y, and Z. Or I might change it for A, B, and C. Okay? This problem will run the same way no matter what 3 variables I use. Okay? So, step 1, again, from what we talked about, we need to multiply by the LCD. We got to clear the fractions. There's two denominators, m and n. Well, that is your LCD. So everybody's going to get multiplied by m and n. M and n. M and n. And again, we're multiplying because we are clearing the fraction. So what does that leave me with there? N. The n cancel out. What does that leave me with there? M. And over here, nothing cancels out. So you got P, M, N. So we cleared the fraction. Step 2, again, our chosen variable. I didn't talk about it before, but it was M. So you can see that my chosen variable's here and there. This is just like what we ran into a moment ago with the C's. When I had C's on two different sides, I need to get them all on one side. So I'm going to take this M, and I'm going to bring it over here. So how do you get rid of a plus M? Subtract M. And again, just like before, these two terms cannot combine. So what do we have left? N equals PMN minus M. Because those two terms cannot combine together. And again, if you're paying attention, you still see that we have two of those M's. I told you a moment ago that if you see your variable twice, that's a hint and a half for you that you're going to be doing step 3, which is a GCF. So what's the GCF we're going to pull out? Again, I told you it's these two guys. Your chosen variable should be your GCF that you usually pull out. Because again, it's repeated twice. So when I pull that M out, I'm left with Pn minus 1. And then now you're at step 4. All those extra variables by who we want, because we want M by itself, all those extra variables over there, we're going to get rid of them through division. We're going to divide the Pn minus 1 away. Pn minus 1. So, what does M officially equal? Slide down and extend a little bit. M equals N over Pn minus 1. There's the answer. And again, we ran those 4 steps. We cleared the fraction to get to here. We put our M all the way over on the other side. So we collected that variable that we wanted. Between here and here, we did a GCF. And then, in the end, we subtracted. We divided out all those extra variables. We did steps 1 through 4 there, just like what we did a moment ago. All right, let's take a look at another one. We'll work this together. Then I got 3 more after this that I want you to try on your own. So here's what we got. This one's a little bit easier than the other ones. So we'll talk through this. You're actually not going to have to use all 4 steps that we talked about a moment ago. So sometimes they are a little bit easier. So on this one, we're looking for K. You still got to do step 1. Anytime you have rational equations and things like that, you want to get rid of that denominator. Okay? Because no one likes working with fractions. So what's our LCD? Our LCD is r squared. Everyone's getting multiplied by r squared. So we know that those r squareds cancel. And that leaves us with r squared E equal to KQ. So if you're looking at this, again, we're looking for K. Do you see more than one K up there anymore? No. So we don't have to worry about step 2, where we got to get our chosen variable all on one side, because that part is done for us. We don't have to worry about step 3 either, because our variable doesn't repeat itself either. There aren't 2 K's up there. So we don't have to worry about pulling out a GCF. So in this problem, all you had to really do was clear the fraction, and then now we're going to do step 4. Which step 4 says get all the variables away from the one that you wanted by dividing. So I need to divide out the Q. Woo, stuff is popping around on me today. So, what does k equal in the end? R squared E all over Q. And there you go. So sometimes you don't have to do all 4 steps, but just keep those steps in mind. Okay? So, it is your turn now. You're up to bat. I've got 3 problems, just like the ones you've seen. All I'm going to do is either change the variables or maybe change what you're solving for. So here we go. Here's your problem. I want you to solve for B. It's just like our beginning one, but instead of solving for C, we solve for B this time. So give it a shot. Okay, so again, we're going to start by clearing the fraction. Everyone's going to get multiplied by C. So what do we have over here? CA equals, the C's cancel, leaving you with B plus C, or 1C if you want to write the 1 in there. You don't have to have it. Again, here's the cool part. This is what we want. Is it already isolated on one side? You bet. Do we have to do any GCFs to this? No, because there's only one B. So all we got to do is get rid of the other stuff that's around it. Now this one is a little different. It's a little different than step 4. Normally step 4 is dividing, but what's going on between the B and the C? We are actually adding. So I can't divide by C this time to get rid of it. I have to subtract, because how do you get rid of plus C? You subtract C. So what does B equal? CA minus C. Because again, we talked earlier why these two can't get together, because they are not like terms. So there it is. All right. Look familiar? Again, I promise you guys, this is one that you need to know. One that you need to know. Just this time, instead of solving for M, you're going to solve for N. Give it a shot. Okay. So, we're going to multiply everybody by that common denominator, or LCM, which is MN, MN, MN. So that hasn't changed for us. It will actually cancel the same way as last time. So that leaves you with N there. The N's cancel out, leaving you with the M. Man, this thing is touchy tonight. So, and then over here we've got P, M, N. So, this looks just like the last problem. The only difference on this one is I changed who you want. We want N. So notice, oh, there are 2 N's. That means we got to do that step 2. Get all these N's on one side. Pick this guy up, move it over there. Minus N. Minus N. So that gives us M equal to PMN minus N. Again, if you're paying attention, you see your variable that is chosen appear twice. That tells you that step 3 needs to be done. We need to pull out the GCF. And there, we pulled out the GCF. So what do we do now? We do step 4. Because we have to get rid of all these extra variables that are multiplying the N. So we divide by PM minus 1. Divide by PM minus 1. So what does N equal? M divided by PM minus 1. If you go back and look at our answer from earlier when we solved for M, this is what it looked like. Notice when I changed the variable, all that happened really was that the M and the N switched positions. You just performed all the same steps. All I did was change the variable. So I got one more problem. Here it is. Earlier we solved for K. Now I want you to solve for Q. Go. Okay. So multiply everybody by r squared because that's the LCD. And we get r squared E equal to KQ. Again, we're looking for Q, so we're going to divide everybody by K because we don't have to do step 2 or step 3. So what does Q equal? R squared E all over K. Thus ends 4.5. You are now required to do all of the homework for 4.5 and the quiz. Good luck.